So now we're going to go over the different types of injection attacks. So we have application attacks or injection attacks, excuse me. We're going over application attacks now. So we have injection. So we have SQL command and LDAP injection. This is any time on the front end that we have an input field and we're trying to inject malicious LDAP or SQL code to then disrupt our backend server or database. Then we have command injection. So this is where attackers inject malicious commands into programs that execute system commands. So this is like on your PowerShell, your bash scripts, right? Command prompt. Buffer overflow. So buffer overflow occurs when a program writes more data to a buffer than it is designed to hold, leading to unpredictable program behavior. We kind of talked about this in the last section when we went over memory attacks, but now we're kind of going over the more specific types of buffer overflow. So we have stack-based buffer overflow, which attackers exploit a buffer on the stack to overwrite adjacent memory locations, including function pointers, return addresses, leading to arbitrary code execution. Then we have heap-based buffer overflow, similar to stack-based, but occurs on the heap, allowing attackers to corrupt memory, manipulate program execution, or cause a program to crash. So the mitigation strategies, guys. So obviously, we want to do input validation as well. We want to implement bound checking into the actual code, and we want to use languages that manage memory automatically. Then we have replay attacks. So replay attacks involve the interception and retransmission of a valid data transmission, often to gain unauthorized access to perform unauthorized operation. So this kind of is also an on-path attack. What we're saying here is we're going to try to capture data, and we're going to try to replay it to an authenticated session to authenticate us, the attacker, okay? So step one, the capturing of data. We sniff network traffic. Maybe we're not using encryption. And then we have a replay mechanism. So we take those tokens or messages or cookies, those authenticated session cookies, and retransmit them. So how do we do countermeasures? We want to implement timestamps, right? Have sequence numbers on our authenticated sessions. That's between client and server. Or have one-time tokens that can help in mitigating replay attacks. Then we have privilege escalation. So privilege escalation involves gaining elevated access to resources that are normally protected from an application or user. So we have vertical privilege escalation. This is where attackers gain a higher level of privileges, often by exploiting a vulnerability in software or misconfiguration of a device. We have horizontal, where attackers expand their access to resources at the same level of privilege they already have. So this is like taking over another user account, okay? So with vertical, you can kind of imagine this as going up the escalator, right? From a standard user to our root user. With horizontal, maybe we have already root user and we're just kind of like moving laterally, right? Or we're using or stealing another credential with the same level of privilege we already had. So how do we mitigate this? Obviously, one way we want to do least privilege principle. We talked about this in Zero Trust. It's something that we should always have on our enterprise. We want to monitor for that unusual activity, okay? We want to make sure that we don't have root users logged in different geographical areas at the same time. That wouldn't really make sense, right? And then, of course, just updating and hardening our systems. Forgery. So an application attack or a forgery attack involves creating a fake document, digital signature, or other imitation of objects of value to deceive others. So we have document forgery. So this is creating or modifying documents to deceive individuals or organizations. We have digital signature. So this is where we can tamper with their fabricated digital signature to make it look authentic, kind of bypassing our non-repudiation protections, right? So how do we deploy countermeasures? How do we prevent this? So employing digital certificate-based authentication, so doing certificate-based, right? Watermarking, and having a good verification process that uses heuristics, right? That can create behavior baselines. Okay, directory traversal attack. So directory traversal involves exploiting insufficient security validation and sanitation of user-supplied file names and paths. So you can see here, like, let's say we're trying to get to the Etsy folder on our web server. If we allow this to happen in the URL, we're going to allow directory traversal. So this happens by exploiting vulnerable scripts. So attackers manipulate variables referencing files with the .. sequence, essentially us trying to navigate through our web server, which may be Linux-based, to get to the Etsy folder. This could also be to access restricted files. So this attack allows unauthorized viewing of files, access to sensitive information, and in some cases, the execution of malicious commands. So let's bring up a Kali Linux box here, guys, and I'll show you how we navigate through a Linux machine to show you that .. the sequence that it was showing you, okay? So you see right here, the URL. Let's say for some reason I deployed a web server on Kali Linux, right? Don't know why, but now I want to go to the root, okay? If I want to go into my Etsy folder or directory, and then I want to see this file right here, which shows me all my usernames, all the users, I can do that. And if I want to back out, I can type in cd ... and that brings me back to the root. So you can see here, and I don't think we're going to have it because this is not a web server. But if I get into the Etsy folder, or sometimes in the OPT directory, here, let's see, ls, -la, grep, www. If we don't have it, but in a web server, if we deploy this web server here or install Apache or Nginx, we would have this www directory. Actually, we can just maybe do this right now. apt install httpd. Let's see. Don't know how to do this off the top of my head. Okay, we'll just install a Nginx web server, okay? This should create a www directory. I don't remember where it is right now. But that's where the web server is going to sit, right? So what we're going to do in a directory traversal attack is we're going to try to navigate via this URL, this HTTP-based attack, to try to get to this file here, okay? Instead of just sticking in the web server files in the web server directory, okay? Let's see if I can find this again. Maybe I'm not doing my search correctly. That's okay. Probably have to reboot. But that's how a directory traversal attack is going to work. Some other cryptographic attacks. So we have a cryptographic downgrade attacks. So this is where we are going to do, attackers are going to force systems to revert to older protocols with known vulnerabilities, like using SSL instead of TLS. So systems are manipulated into using weaker cryptographic algorithms or maybe shorter key lengths that then we can compromise. So we can see here this attacker sitting in the middle here, taking our TLS session and downgrading it to SSL. So how do we mitigate this? Make sure we enforce strong cipher suites. So we have HTTP headers that we can enforce that say, hey, you need to use strong cipher suites, okay? You need to use TLS encryption. Something like an HSTS enforcement, okay? Collision attacks. So collision attacks occur when an attacker finds, this is a hashing vulnerability, guys, finds two different inputs that produce the same hash output. So like MD5, what we're talking about here, the whole point of hashing is to verify integrity, meaning no two inputs should have the same hash, and every time I run a hashing algorithm against the same input, I'm going to get the same message digest, okay? So what we're going to do here is be aware of collisions. So if MD5, let's say I have this input, hello world, and I run it against MD5, and I produce this output, 7FCE, okay? That's my small little hash we're going to do. And then I take this input, what are you doing? And I run it against MD5, hashing should produce me a unique output. But if I get the same thing, that's a collision, okay? So now what this can potentially do if we're using cryptographic hashes that are vulnerable to collisions, our digital signatures no longer provide authenticity. They can fall victim to forgery. We can't have non-repudiation. So it's important that when we're using cryptographic hashes, we're using secure ones like SY0-256. A birthday attack. So this is another cryptographic attack that's going to attack passwords, right? So the birthday attack exploits the mathematics behind the probability theory of the birthday problem in cryptographic arena to find collisions in hash functions. So the attack utilizes the surprisingly probability that in a set of randomly chosen people, some pair of them will have the same birthday. So in cryptographic implications, it means finding two different inputs that produce the same hash output more easily than actually brute forcing it. So what we're saying here in a birthday attack is that, hey, we suspect that maybe this password and this password may have the same hash, okay? So how do we mitigate this? Employing hash functions with larger hash values and understand the limitations of hash functions. So some other password attacks we're going to go over is spraying. So password spraying is a type of brute force attack that attempts to access a large number of accounts with a few commonly used passwords. So with this attack, we're trying to compromise multiple users at once using the same common password. So how do we mitigate this? The same way we do with any password-based attack, guys. Use strong, unique passwords and always employ multi-factor authentication. And then we have a brute force attack, something we've talked about already. This is where we try to attack a specific user and try to reuse the same password, or excuse me, trying to reuse different variations of similar passwords over and over. Just trying to brute force our way in, right? And again, with the brute force, it's important to know that this is against a single user, okay? How do we mitigate against this? The same way we do with every password attack. Implement account lockout policies. Always use multi-factor authentication. And then again, have strong password policies for your users. Make sure they have to use complex and strong passwords, okay?